Hello, this is Math 111. And this is section 4.2. All right, let's get started. Okay, so this whole chapter is on exponential functions. And the definition of an exponential function is some constant c with a base to the x. It's important to note that both c and a are constants. Right. A cannot be 1, because if a is 1, then it would just be 1 the whole time. And c cannot be 0. The domain of the exponential is this, right? So you can put any number in, right? So here we go. Okay, so let's just kind of evaluate these, how we would evaluate them with our calculators. 0.5 to the 1/3 would equal to, I would put 0.5 caret parentheses 1 divided by 3, close parentheses, and then hit enter. How about this? 2.8 raised to the 2.5. That is basically saying 2.8 squared times the square root of 2.8. But the way that we're going to put this into our calculator is 2.8, then do the little up arrow key, and then a parentheses, and then 2.5, close parentheses. So what's it look like to graph these? First of all, if you have any basic like function f of x, c(a) to the x, when x is 0, this is just going to be 1, so your intercept's just going to be 0, c, right? So cross at whatever that c is. And then as long as a has to be greater than 0, right? So it's going to look like this and grow exponentially up here. As x goes to infinity here, it's going to go up to infinity here. As x goes this way to negative infinity, then this is never going to cross 0. It's never going to be negative, because all you're basically doing as you go to negative infinity is like 1 over a large number, right? So a to the x would be 1 over a large. 1 divided by large is, close to 0, approximately 0. Okay? So let's see here. Now, if a is greater than 1, that's how it works. If a is less than 1, then basically you're looking at a fraction. If a is less than 1, because you're taking, if it's between, not less than 1, but a is between 0 and, right? Then you're taking a fraction and then multiplying it. And when you multiply a fraction by itself over and over again, it becomes smaller. So what that does is it flips your graph to go this way, right? If a is a fraction, it's going to get smaller and smaller and smaller as it gets bigger. Okay? So, all right. Also, you can flip it over the x-axis. There we go. All right, so when I flip it over, it goes over this way, like that. All right. So this would be if c is negative. It essentially flips the whole thing over the x-axis. All right, there is a special base that we know a lot about, and it is called e. All right, And it is equal to 2.71828182884 dot. D is an irrational number. It never repeats, and it never repeats, and it never terminates. It's a pretty cool number though, and it's what happens when you take this fraction, but you might recognize it as the compound interest formula, and you let x go to infinity. Right, if you take 1 plus 1 over 2, and then 1 plus 3, and so on and so on, if you let x go to infinity, then you end up with e. And that's pretty darn cool, right? So, like as x gets really, really large, the number that this repeats, like it like tops out at this number right here. And that is e right there. And the function y equals e to the x, which is essentially y equals 2.71828 to the x, is a function that pops up all over in lots of different places in nature and in science. Ends up being the base of essentially the normal curve that we use in statistics. So there's lots of graphs and things that go with the letter E that show up all the time, right? E looks just like, if I am graphing y equals e to the x, it looks like any other thing. It's when this is 0, it's going to cross at 1, right? Because that's what my constant in front is. And then it's going to go up like that, right? If I move it, I put x plus 3 in the parentheses up here, of course that's going to move it to the left 3, just like any other shift that we're aware of. If I add a 3 after this, it's going to move this 1 up to 3, and it will look like that. So it behaves just as you would expect any other things to know. Now, I mentioned that this is the compound interest formula. So if I'm looking at an interest rate, this is the principal you put down, 1 plus the rate that you're given, divided by the number of times it compounds annually, times the number of times it compounds annually, raised to the power of the number of times it compounds annually, times the number of years. So let's say I took out a $1,000 loan at a rate of 7% that compounded monthly for 5 years. So it's going to compound a total of 60 times. That's why that's 60 up there. The rate, though, the 7%, which is this annual interest rate, is compounded every month. So we divide it by 12. So that's what I'm paying per month. And then I'm adding that, and so on. If this becomes a minus, then this formula is the formula for depreciation. Like, what if my car depreciates, 8% every year? Then it would be every year, so that 12 would go away, but 0.08, and then for each year, and so on. Right? Because if you look at this, this is essentially right? Remember that x is 1 plus 1 over x to the x power. That's equal to e. So if you think of this right here, as your x, then if you wanted to compound every second of every day, your formula ends up becoming, this is for compounded continuously, again, every second of every day, the principal you put in, e raised to the rate that you're doing, number of years that you're doing it, right? So you essentially kind of factor out this part of the e, and this becomes the formula that you're working with. Like I said, for depreciation, it's the same formula. You just switch this, what you're adding on in interest, to a minus sign, because you're subtracting it from your rate. And I think that should give you enough to work on this homework. Good luck, and let me know if you have any questions.